Remember that the nth root of x to the n equals x, given an nth root in the denominator, it will need to be rationalized. To rationalize, find the complement of the nth root that will create a perfect root in the denominator. Multiply top and bottom by the complement. Simplify. Here are some examples. Alright, so here we have 1 divided by the fifth root of x to the third power, which cannot be simplified further. However, if this was x to the fifth power, we would be able to cancel out this radical. So let's multiply this times the fifth root of x squared. X to the third power times x to the second power gives us x to the fifth power, and then that radical cancels out, and so does the exponent, leaving us with x. Because we multiply top and bottom by the fifth root of x squared, the numerator has this fifth root of x squared in it, so here is our answer. Down here, we have the sixth root of 4 over 9. 4 can be rewritten as 2 squared, 9 as 3 squared. Now, we see here that we have the sixth root of 3 squared, which we can't simplify further. However, if we then multiply it by the sixth root of 3 to the fourth power, then all of a sudden we would have the sixth root of 3 to the sixth power, and that cancels out, leaving us with 3. So we multiply top and bottom by this radical, and we get this for our numerator, and this is our answer. Let's try 2 examples. So if we wanted to cancel this radical out, we would need this to be p to the 7th power. So in order to do that, we need the 7th root, which is the same as it is here, of p to the 5th power, because p squared times p to the 5th will give us p to the 7th. So we have to multiply the top by the 7th root of p to the 5th as well, and that gives us the 7th root of 2 times p to the 9th, which we can write as p to the 7th times p squared. So this is p to the 9th, which is 4 plus 5. All right, and on the bottom, we have the 7th root of p to the 7th, because p squared times p to the 5th gives us p to the 7th. And that means this and this cancel out, leaving us with just p on the bottom, and this one cancels out, so we get a p out front, and so that gives us p times the 7th root of 2p squared divided by p. And then this p cancels with that p, leaving us with an answer of the 7th root of 2p squared. Over here, we have, I'm going to just rewrite this with 5th root of n to the 4th divided by the 5th root of 4m. Now, we think we should just multiply it by the 5th root of, well, this is m to the 1st power, so we need m to the 4th power. However, that won't cancel out this 4. In order to cancel out this coefficient here, we need to have an 8 in there, so that this will become 32, because 32 can be rewritten as 2 to the 5th power. All right, so we're going to multiply top and bottom by the 5th root of 8m to the 4th. The numerator here times this numerator gives us the 5th root of 8 times m to the 4th times n to the 4th, which cannot be simplified further. But on the bottom here, we have the 5th root of 32 times m to the 5th. Now 32 is 2 to the 5th, so that would cancel with that, leaving us with 2 on the bottom. And m to the 5th root, those cancel, leaving us with just m. So now the denominator is 2m, and the numerator is this radical here. And there are our answers.